So in this video, I'm going to create a shader which is going to distort the pixels of our cube. After creating this, I'm going to optimize this shader for the best performance. The way we are going to create this shader is by displacing the pixel of our texture. So let me explain better. This is our cube, and each point on our cube has a UV coordinate. These UV coordinates are not unique, so also 2 points on our cube can have the same UV. And each pixel is associated with a UV coordinate. And when we set the albedo color, we set each pixel according to the UV position. But what we are going to do now is to modify the UV, so instead of sampling the pixel at this position, it is going to read this pixel at other position. And based on how you modify UV, you are able to create different shader effect. For example, you can also create magnifier effect by this method. But in this video, we are only going to distort our pixels, so they will have watery-like effect. In our case, it is important that we should not modify the value of each pixel completely random. If you do that, you will get this result. And if you want to get this kind of result, that is okay. You can do it. Other thing to note is not to displace UV too much. And if you do that, you will get this result. So the way that we are going to achieve this effect is by a smooth type of noise, like Perlin noise. So in this kind of noise, each pixel does not change completely random, and you can see a kind of a smooth transition between each pixel. So enough talking, let's do it in Godot. So this is my cube. I just add a shader material to it, and first I'm going to define two texture uniform for my noises. I also define a uniform for my albedo texture, and then I set my albedo to that texture. My albedo is a texture which some number is written on it, but you can have any type of texture. Next, I'm going to generate a noise for the first noise. Godot has a texture type which is called noise texture 2D, which is going to generate noise for you. Under noise, create a fast noise type and make sure to check seamless, so your noise texture will repeat properly. After that, create noise number 2 in the same way, but make sure to change the seed number, so you will have a different noise. Well, now I want to read from these noises, and then modify our UV coordinate according to these noises. As we are going to move these noises later, I'm going to create a custom UV for our noises. Right now, I just set my noise UV equal to my original UV, but later I'm going to change that. For each pixel, we need two random noise values, one for X direction and other one for Y direction. This is why we created two noise. What I'm going to do now is to create a vector 2 which contains these two random values. For value 1, I'm going to read from noise 1 with noise UV, and for value 2, I'm going to read from noise 2 with noise UV. Well done. If you look at your noise, the noise is look like this now. Now what I'm going to do is to create our base UV. This is the UV that is going to read from the albedo texture, and we are going to change this UV with our noise values. Okay, done, but the result is not what we want. That is because each value of noise changes between 0 and 1, and that is too much. So I define a float uniform which is called distortion factor, and then I multiply this factor to my noise. And as you can see, we have our original picture back, and that is because the distortion factor is 0 right now, and that's make all noises value to 0. And now if I change the distortion value, you can see it is going to distort our texture, and we can control the amount of distortion with this factor. Now let's animate this distortion. The way I animate this is just by adding a time to UV. And as you can see, it is waving too fast. So I define another float uniform which is called distortion speed, and then multiply time with this distortion speed. This way I can control the speed of the animation. If you look at your noise, it does look like this. But one thing is that this noise seems repetitive to me. To avoid that, one thing you can do is to create another random noise, but this time this random noise is going to move in other direction. And then add these two noises together. But still it's repeating to me. And to avoid that, I just add a random value to the second noise UV. So up to this point, everything is working, but this shader code is not optimized. We can reduce the processing needed for this shader by a great amount. So look at the noise UV. We don't need to calculate noise UV for each pixel. We can calculate instead the noise UV for each vertex. Our cube has 8 vertex, but it has thousands of pixels. And by calculating noise UV for each vertex, we can reduce the amount of the process by a great amount. So we define noise UV1 and noise UV2 as a varying in global scope. And this way we can calculate them in the vertex shader and then send this information to the fragment shader. So cut this here and paste them in a vertex shader and then remove the vector tool. And that is done. We optimize it up to now a lot more. But we can still optimize it. In Godot 4, a new function is added which is called FMA. This function multiplies two numbers together and then add it to another number. But the interesting thing is that the algorithm behind this function make your shader faster by 10%. So as you can see, for noise UV, we do the same thing. We multiply time by a number and then we add it to another number. So I will do this operation by FMA. And it is done. Please note you cannot change base UV in vertex shader because the pixel distortion should be calculated for each pixel. But you can optimize this by FMA function. And I leave this to you. So guys, I hope this video was helpful. If you have any suggestion or question, leave it in comment. Until the next video, bye.